section 2.5, and this is the third video in this section. Today we're using zeros of polynomial functions still, and today we're going to do the opposite. In the previous videos we've been solving polynomial functions. Today we're going to go the other way around. We're going to get the zeros and we're going to actually find the equation. So we're going to work backwards. Now, in order to do this, you need to know one thing. The first is that, well, two things. The first is that the degree of the polynomial equals the number of roots. And if that root is repeated, if it works more than once, it's counted separately. Also, if you have an imaginary root, a plus bi, then a minus bi, its conjugate, is also a root. Now, we'll put all that together and we'll try to find the equation of our polynomial. So let's take a look at our example. We're finding a fourth degree polynomial function with real coefficients. That just means that the numbers in front of the variables are real. And that 2 and negative 2 and I are zeros or roots. Now, it's a fourth degree polynomial and I only gave you 3 roots. Remember, all the imaginary roots happen in pairs. So since we know I is a root, we automatically know negative I, its conjugate, will also be a root. The final piece to this is that if I put a 3 in for x, I'm going to get negative 150 for y. And we'll see in a second how that's going to help me. Now, first of all, if I just want to build this backwards, if I'm thinking about the zero product property backwards, my zeros are going to go in opposite into the equation. So my x minus 2 is going to go in as x plus 2. My x plus 2 is going to go in as x minus 2. And then same with my i's. Now, that would be the equation. I obviously need to multiply all this together and make it look like a polynomial. The only problem here is that I haven't taken into account yet the coefficients. That's where this f of 3 equals negative 150 comes in. There's usually some sort of stretch or compression in front of all of our equations, an a value. Now, I don't know what that is, but I know that if I plug in, so that equation is going to equal f of x. Now, I know if I plug a 3 in for all these x's, the answer should be negative 150 using that point. And now I have to go through and I have to solve for the a value. So let's see. 3 plus 2 is 5. And here we're going to get 1. I'm going to have to multiply 3 minus I and 3 plus I. Because I don't know really what to do right now with these i's. So go ahead, on the side of your paper, use a rectangle. Three plus I, 3 minus I, we get 9, negative 3I, positive 3I, and negative I squared. The nice thing is that the positive 3I and the negative 3I cancel out. And we know that a negative I squared, well, I squared is negative 1, and negative 1 is positive 1. So I squared is negative 1, and negative 1 is positive 1. Now, this totals to be 10. So the nice thing here is that those two multiply together, just multiply to make 10. So that equals negative 150. We've got 50a equals negative 150. And so our a is going to be negative 3. Now, the polynomial here would be f of x equals negative 3 times, and actually let's start this on a new page so we can see better. The polynomial would be f of x equals the a value, negative 3, x plus 2, x minus 2, x minus I, and x plus I. Now, we're not used to our polynomials looking like that. We want to go ahead right now and we're going to multiply all this together so that it looks like a normal polynomial. Let's start with the x plus 2 and the x minus 2. If you need to, go ahead and multiply those with a rectangle. You'll get an x squared minus 4 when you do that. We have negative 3 in front still. We'll multiply x minus I and x plus I with a rectangle. And we should get an x squared minus I squared, which means x squared plus 1 in the end. And let's go ahead, we'll do that real quick. X minus I, x plus I, x squared, xi, negative xi. That's nice, those will cancel out. And then there's that negative I squared, which equals positive 1. Now I'm going to multiply these two together once again with another rectangle. So lots of multiplying right now. X squared times x squared is x to the 4th. X squared, negative 4x squared, and negative 4. So right now, f of x equals negative 3 times all of that. X to the 4th minus 3x squared is minus 4. And the final piece of this puzzle then will be to distribute the negative 3. So we get negative 3x to the 4th, positive 9x squared plus 12. That would be my final polynomial with those roots in which f of 3 equals negative 150. If you wanted to check to make sure you did your multiplying right, you could put a negative 3 in for x and make sure you get negative 150 as your answer. I want you to go ahead and do the same thing for this one and bring your answers to class tomorrow. Now be careful with the wording. It says find an nth degree polynomial. And then they tell you what n equals right there. So it's a 3rd degree polynomial. So go ahead and try this and we will start class with this tomorrow.